Welcome to the Smithsonian's National Air and Space Museum. This morning we are in our Moving Beyond Earth gallery where we deal with the Space Shuttle and the International Space Station era. We have a live audience of students and families who are visiting the museum. I'd also like to welcome our viewers online. This is being webcast and also it's being broadcast on NASA television. So welcome to all of you who are watching from outside the museum. It's very exciting to have another astronaut with us today. He is astronaut Reid Wiseman, who has just returned from a 6-month stay on the International Space Station. Now, if you haven't had a look at the International Space Station online before, we have a model of it here in the gallery. This is only a 1/25th size space station. So imagine 25 times bigger than this, and you get to a space station that's the size of a football field, or it's actually about 2/3 the size of our museum. It's a huge living and working space in Earth orbit that's been occupied continuously since the year 2000. Reid just returned from his 6-month stay, during which he did spacewalks. He tweeted live from space. He did scientific experiments on board, and he's come back today to tell us about that. Before he went to space, though, he had some interesting other activities in his life. He's kind of like a neighbor to us here. He grew up in Baltimore. His parents still live in Maryland. He spent a lot of time in Virginia when he was in the Navy. He's a fighter pilot. He's landed on aircraft carriers. He has quite a history of doing high-risk, high-adventure activities. So please join me in welcoming today astronaut Reid Wiseman. Thank you.
Thanks.
Good to have you here.
Make sure my mic's going. Can you hear me out there?
What is this?
For me to come to the museum here, I came here many times as a kid, and so this is kind of where aviation built its fundamentals in me. And this is where you get to look at all of history, from gliders all the way up to rocket ships. And I remember my brother and I running through this museum, and so in many ways, this is me coming back to the birthplace of my dream to fly in space. So we have a little memento, a little montage from our mission. So
lovely. And that is your mission patch?
that's our mission patch, and then a bunch of photos. That was flown in space.
Wonderful.
I was too. All right, thank you.
Thank you.
So I don't normally get a circular platform on which to stand. It'd be better, maybe I should drop down to the floor. But looking out real quick, I have an old flight instructor of mine who taught me how to fly the F-14, sitting in the front row. That's great. And then I have a bunch of new friends in the back. And I do want to take a second, since we're here in this museum, that if anybody's a teacher, be proud of what you do. And I'd like to give a round of applause to all the elementary, middle, high school teachers that we have out here, because you're shaping the future. And we got two screens here, so hopefully everybody can see, because a big part of flying into space is getting to look down at our Earth and getting to see kind of a different perspective of what it's like. And so if I can hold the attention of, I'll pick these guys. If I can hold their attention, then I'll be doing good. If I see them start to fidget, then I'll speed up. But I'll talk for about 30 minutes. We'll kind of go through my astronaut class, who's a member, a little bit of our training, and then we'll launch up to the space station. We'll go through a little bit of life in zero gravity, some of the science we're doing, and then we'll take a few looks out at our planet. I'll kind of explain what we're looking at, and then I'll ride the rocket home, and then we'll do questions. So I'll talk for maybe 30 minutes, and that should leave us about 15 minutes for some questions. And I think throughout, people will come and go as they please. This should be a fun day for everybody, so if you got something else you want to do, go do it. All right, and I have to say next when I want the slides up there. So that was just an intro slide of me out on a spacewalk, and we'll get to that in a little bit. So next. It's a little video just to give you a taste of what our Earth looks like from space. So you can see the sun setting behind one of our cargo vehicles there. And these are all time lapses for the most part. So it's basically a photo a second, and then we stitch them all together. So life is going pretty fast. There you can see some lightning. In a second, you'll see what it looks like to look down from above on lightning crawling through the clouds. Our solar arrays as they track the sun. Obviously, we're not flying that fast. Here we're over Africa, and we're coming up on the Mediterranean, and I love that contrast. This is the Bahamas, the bluest water you could ever see, beyond your imagination. Northern and southern lights, looking down from above, is a whole different perspective. This is us coming up over Europe. I flew with the German astronaut Alex Gerst, and so he did a lot of great time lapses over Europe. That's what it looks like when you have a full moon bouncing down on your Earth. It's really great at night. And here in just a second, Orion's belt will rise. I don't know if you can see it. It just rose through the atmosphere. And that's the constellation I think as a kid you get to know the quickest, the easiest, is that Orion's belt and the Orion constellation. All right, next slide. When I launched into space, we've been flying into space for a long time. 1960s we started, and a lot of folks have gone. And I was trying to put it in perspective into my head of what is it like to be in space? How many have gone? What's it all about? And this is the number I came up with. We've sent 538 people throughout the entire world into low Earth orbit or beyond. So this number is everybody that walked on the moon, everybody that's been in orbit. That's coincidentally the same amount of people that can fit in coach class of an A380 Airbus airliner. So there's really not a whole lot of people. It's a pretty unique experience to get to go into space. All right, next slide. And here we have our astronaut class, and I won't go through every single individual. I got hired in 2009 with these folks here. I think it was somewhere between 3,000 and 4,000 people applied to 2009 class, and this is what we ended up with. So people ask what it takes to be an astronaut. It takes a great background, a lot of math, a lot of science, but it also takes an intangible, and that is luck. It takes a lot of luck to get hired, especially when you're dealing with those numbers. So in this picture, we have men and women. We have folks from Japan, folks from Canada, and all over the US. We have military test pilots. We have doctors. We have engineers. We have scientists. And that's really what NASA's looking for, is a broad spectrum of people. We even have school teachers. We didn't hire any in our class, but we have school teachers down there, Joe Akaba and Dottie Metcalf. So next slide. A little bit on our training, just some of the fundamental things that we do in our training. This is my crew, and we're standing just outside of Moscow, and it's February, and it's 30 degrees below zero. And they dump you off there for 3 days, and the only thing they give you is what you actually have in your Soyuz, which is our spacecraft. That's the only thing you have to survive. So you can see there, we have a little bit of cold weather gear that we're wearing, and we have a teepee that we have made using a parachute and some fallen timber. And you can see the top of the teepee starting to turn brown because we've had a fire going on the inside to keep us warm at night. And we lived out there for 2.5 days, 3 days in that minus 30 degrees. And the best part about this training is I thought it was all about survival training. But in the end, it was really all about crew cohesion and getting to know these other two guys I would fly into space with. And that's really what I took away. We became a really tight-knit group after living together in such a harsh environment. All right, next slide. In the off chance you get to do a spacewalk, you really have to practice this task before you launch. And so here you can see the pants that I'm wearing make me look like the Stay Puft Marshmallow Man. They're huge pants to keep you protected out in space. I'm also wearing a liquid-cooled undergarment. And if any of you have never had liquid cooling in your shirts and pants, I highly recommend it. It's great, especially here in the summertime. It's great. And so we would hook our cooling garment into the spacesuit, and it would provide cold water through all these little tubes, and it feels real nice. And then my left hand is on the hard upper torso, which is where all of our controls and the machinery of the spacesuit live. Next slide. And how we practice for that on Earth is we have a gigantic pool down in Houston, Texas. And we have an entire space station, not that size, but real sized. So what was it, 25 times that size. And it's underwater. And when we go underwater in the spacesuit, we have divers that are there, and they make us neutrally buoyant using weights, and we can pretend like we're in space and go around and fix the space station. This was some of the best training that I did at NASA. When I went out on my first spacewalk, I just reached out the airlock, and there was a handrail that I knew was going to be there because it was there in the pool. So this is really relatable analog training. Next. We have no doctors on board, and I'm a Navy pilot. I don't like the sight of blood. I don't like anything to do with surgery or anything like that. But we had to learn how to do that. And this poor mannequin here gets abused by every astronaut launching into space, so he's pretty beat up. But he's got EKG, he's got the AED sensors on him, the defibrillator, and I think Max is a little bit off the screen, and he's got this thing called a bone injection gun, which just shoves this huge needle into your calf and supplies IV fluids in an emergency. And so we have to train in CPR. We have to train in basic medical care. Next. Oh, I love this picture. So through that little window, I'm sitting in a spacesuit, and I'm in a vacuum chamber in Russia. So there is no air in this room at all. And the whole point of this training is you gotta trust your hardware when you fly in space. It's going to put you in some really weird environments. And so in this chamber, there's no air. If my spacesuit leaks or a glove pops off, that's it, I'm done. And so you sit in there for 2 hours in that vacuum chamber with all the air sucked out. And I can tell you, when you sit there at first, you're nervous, you're shaking a little bit, and anytime you move, you can hear like a pop or a creak in your spacesuit, and you just instantly freeze. You're like, all right, I'm still alive. And then you like settle back and you hear, and you're like, ah! And then you settle down. And after 2 hours, you have total trust in that spacesuit. They're all custom tailored for us, and that's the one that I would wear in the Soyuz when I launched and when I came back to Earth. All right, next slide. And we got to learn how to do the science that we're going to do up there so that we don't waste a lot of time. So here, I'm actually doing an ultrasound of my heart. And you can see on the screen, I have an instructor there who's also one of our ultrasound researchers. And he's pointing out heart valves. And I can actually watch my heart beat on this screen. If you've never done that, it's really weird. It's like a weird sensory overload that comes into your head. When you feel your heartbeat, you watch your heart valves flopping around, and it just doesn't feel right at all. But I learned all that so that I could go up and do this science when I was on the space station. Next slide. And I had to learn my rocket ship. And the only thing I'll touch on here is I flew with the Russians, launched out of Baikonur, Kazakhstan, and everything was in Russian. That manual I'm holding, all in Russian. All those knobs on that display, all in Russian. The guy sitting next to me talking to Mission Control, it's all in Russian. And so I spent a solid 4 to 5 years of my life at NASA with a Russian tutor learning that language. And by the time we launch, we're pretty good at space Russian. So I'm not too good at Russian, but I'm pretty good at space Russian. All right, next. And here's that same class that you saw earlier, but this is us in the back of a C-9 airplane, and we're floating for the first time in our lives. And so you get about 20 seconds of weightlessness in the back of this airliner as it does a parabola. So it basically pitches up, and then the pilots push the stick forward, and you get weightless. We like to do it in fighters all the time when we were younger, but this was awesome. And you can tell by the look on our faces that this is boring, and it's no fun. And I don't recommend it to anybody. So if you ever have a chance to do a zero-G flight, say no. Don't do it. No, it's great. It was so much fun. We had a blast. All right, next slide. And at the end of about 2 years of training, they give you the keys to your rocket ship. And there's me, Max, and Alex standing at the business end of our Soyuz. It's actually a very small rocket. It looks like a little sports car sitting there, but you can see there's some serious firepower at the back end of that machine. And by the time I got hired in 2009, by the time I launched in 2014, I was absolutely craving the ride on this machine. Next slide. How many kids are train buffs out there? When I grew up, that was what I loved. I loved trains. And so when I got to see my rocket riding out to the launch pad on this train, it warmed my heart. It would be better if it wasn't a helicopter, if it was a fighter jet escorting it out there, but I couldn't get everything I wanted. An Su-27 banked up around there would look good. But that's the middle of Kazakhstan, truly the middle of nowhere. I joke with my kids when we're driving through like the western parts of Virginia that we're in the middle of nowhere, but this is truly the middle of nowhere. All right, next slide. And here's my crew. So just real quick, over on the left, the guy that's lacking hair is Alex Gerst. He's a German geophysicist, studied volcanoes, actually lived on the rims of volcanoes, dodging like these things called bombs as they're getting ejected out of a volcano. So he is a lunatic. He has done a lot of parachute jumps. He's lived in places that I would never even volunteer to go ever in my life. And he's a super smart guy, salt of the earth. He was our book of knowledge up there. And then in the middle, we have Maxim Viktorovich Maksarayev, a Russian fighter pilot by trade. He flew Su-27s. And when I joined the Navy, that was my enemy, the Russian fighter pilots. Those were the people that we trained against. And then here we are, and in the end, we're best friends. So what I love about it is if you get under the political levels and you got one mission, you're one group of people, and you want to go out and do that mission. And then you got me over there on the right side. Next slide. All right, so let's get us off the planet and up into space, because that's really what we're here to talk about. People ask me the hardest part of flying into space is saying goodbye to your kids. So that was me on the bus, heading out to the launch pad, saying goodbye to my little girls, and that's real hard. And then here we have the head of the Russian Space Agency, and he's giving us all best wishes, tells me that he built us a good rocket, which was very reassuring at that phase. And then we're climbing up the ladder. You can see that rocket behind us. It's alive. It's like breathing. It's rumbling. It's shaking. It's ready to go into space. We sit in there for about 3 hours, and then it's time to light the engines. They burn for about 10 seconds before liftoff. And you can feel it inside. You can feel it starting to come alive. It rumbles a little more. You can hear that sound, and that's liftoff. And you can see it's really pretty gentle. We launch at 2 in the morning, pitch black outside, and there's my wife with my kids. There's my brother, my mom in the lower left. And the only thing illuminating right then is that huge fireball coming out the back of our rocket. That ride to space, it's only 9.5 minutes. It's nothing. It takes us from 0 to 17,500 miles an hour in that 9.5 minutes. So you can imagine the forces on the body throughout that. It's a 3-stage rocket, and each one of those stages takes you up to about 4 times Earth's gravity. So in the end, you're getting pushed back harder and harder and harder in your seat. Then first stage gets done, you kind of float forward, and second stage comes on and starts that whole process over. Pushes you back harder and harder and harder into your seat. And these images, there's Mission Control, Moscow in the upper left, us riding the rocket. And then this is going to be main engine cutout. And you can see it's very dynamic. It's actually kind of jolts you really quick when the engine's cut out. And we're in space right now, first time ever. And you can see there is this feeling of extreme happiness. It's tough to see Max, but we made it. You know, I've dreamed of this my whole life, and now we're there. That's a toy that my daughter gave me, Geographic. And then we had a GoPro mounted to the control panel, and this is our first look outside. And I love that reaction from the crowd, and because that really is, that's the awe moment. And that's the first look outside. And I had dreamed about this for so long in my life, and I had looked at so many pictures, and I'd been to so many great displays like this, and I was really worried that after 9.5 minutes, I'd look outside and go, But I can tell you, when you get to see that with your own eyes, and you're floating, and you feel really weird, and everything is crazy in your body, there's nothing like that. That is the ultimate moment of youth, of passion right there to look outside at your planet. All right, next slide. So once that 9.5 minute launch ride is over, then we're in space and we're hurling ourselves around the planet. We got to catch up to the space station. And that takes about 6 hours. And that's us on the left docking to the space station on the right. Totally automated system. We never touched the controls. All we had to do was talk to Mission Control and keep ourselves alive. And the rocket took us up there and got us docked. Here in a minute, you're going to see Alex Gerst come through the hatch, and then I'll follow him a few seconds later. And I'm sure everybody in this room has had that dream where you're floating, and it's a magical feeling. But I can tell you, when you put the whole human body in weightlessness, there's not a whole lot magical about it initially. There's a whole lot that doesn't feel right. So you can see me come through. I'm timid. Here, Swanee, my commander's just going to grab me and kind of drag me through the space station to get me where I need to go. And if we can go to the next slide, I'll kind of hit on some of my initial feelings. I had trained essentially for 5 years for this mission. And so I knew the space station inside and out. But what I didn't know was the space station inside and out when you have no gravity. And so you take gravity away, and now my environment was unbelievably confusing for the first 2 or 3 days. I would get lost. There's no up or down. There's no walls. There's just stuff everywhere. And it's an operational laboratory. I mean, it's a mess in there of wires and experiments, and it was crazy. And next slide will kind of start to hit on some of that. My stomach felt full all the time. So imagine you turn off gravity, and now everything you ate for breakfast, that blueberry muffin, that cup of coffee, maybe you had a nice big glass of milk, well, now that's got nowhere really to sit. And so it's like up to there, like way up to there. And so you know you need to eat, but you don't want to eat. You know you need to drink, but you don't want to drink. It's just like, this is not good. But it gets better. All right, next slide. Around day 3, we were getting better at floating. It's real funny. Alex and I were both rookies, and we would just knock stuff off the walls like crazy. You'd go floating into the US lab, and you would just plow stuff right off the walls. And so Swanee would come behind us. He had been up there for three months already, and he would just gently be putting all the stuff back that we had knocked off. He wasn't yelling at us. He just knew it would get better over time. And then the interesting thing for me was how much the tops of my feet hurt. When we get into space, the first thing your mind wants to do really is get you oriented like this. And so we have handrails everywhere, and you'll lock your feet under them. And then you pull up with your toes to stabilize yourself. And then the tops of your feet end up getting blisters and calluses on the tops of your feet. All right, next slide. My first run on the treadmill, this was something that I had tweeted, that my heels were tingling, felt weird, and the food bouncing in your stomach. So not only do you feel full, but now you have to feel what it feels like, that food bouncing off the top of your stomach and then back down. And it's a really weird kind of, it almost felt like I had eaten a bunch of golf balls and they were just kind of hurling themselves around in there. So I don't know. I can't do cartwheels. Maybe it's the same sensation, but I don't think so. It was weird. But it got better. All right, next slide. And then I woke up on day 4, and it was like magic. Like a fairy had visited me in space and just said, everything will be good from here on out. And I woke up. I felt great. And then I started to realize that space is like every lazy man's dream. You can just float from one side to the other without walking. You can lift up this whole stage and just push it across the space station to your buddy over on the other side. And everything started to get really easy. And my mind loved it, my body loved it. And you could tell that the human body is an amazing adaptive machine. And it just took this this kind of new challenge, just swallowed it up and said, all right, it took me 4 days. And then I felt great. All right, next slide. So when we do space tourism here in the future, make sure your mission is at least 5 days. I guess that's the takeaway from that one. Because the first 4 are not going to be super. All right, so real quick on our space station, you can look at the model, you can look in the screen. Anything that you see running horizontal there is all truss work. And that is just there to support those huge solar arrays, basically, that are out on the outside. Our space station, we have no engines, we have no nuclear reactor. All the power we get inside comes from the sun. And it's those arrays that are kind of orange-looking vertical on the sides. Then in the center, you see what looks kind of like an X-wing fighter docked to the very back, it's the front in that picture. That's a European resupply ship. And then anything vertical, I do have a laser pointer I can try to point out here. Hopefully I'm doing a good enough job explaining it. But this vertical part right here and this little T there, I'll go to the other screen too. This vertical part here and then the little T there, that's the pressurized volume. So that's where we live. That's our home. And in this next slide, I'll show you on this screen, and I'll show you on that one. I'm going to start right here against this wall. So I'm kind of tapping on this wall. And I'm going to float all the way through to this side. So I'm going to go from back here, and I'll float all the way through to this side. And for those of you that have seen this video before, just listen to the fan noise, try to pick up on some of the nuances. For those that haven't, just kind of enjoy it. But I'll start in the Russian side. It's real confined. There will be a joke at the beginning about that. And then when I go through in the US side, you can see it's all launched in the cargo bay of the space shuttle. And that's a big machine, and you'll see how big that part of the space station is. All right, go ahead and play the next slide. Okay, here we are at the back of the ATV. We're at the very back end of the space station. We're going 18,000 miles an hour in this direction. And so I'm going to kick off and we'll do a quick fly through the stack of the International Space Station. We'll pass some fun things on the way. Oh, доброе утро. Dinner table again, got Max. Ah!
It's very difficult to squeeze through the Russian segment.
Especially when Max is here. And now we're going through into the FGB. This whole module right here is all storage. Just storage. Nice flight path here. Should be able to make it. All right, down into node 1, station's gonna open up. Butch, go high. Quick, so now we're coming down into U.S. sovereign territory. Quick aileron roll through the lab, into the ball form. A little spin into node 2, over Alex's crew quarters. And here we are at the very front end of the International Space Station. Still going 18,000 miles an hour. I rounded up. I think it's 17.5, but it's fast. So you can see from that, it's a huge volume inside. A lot of people wonder if you get claustrophobic up there or you want to like escape. You never do. It's huge. And being weightless, you no longer have this confining floor, ceiling, wall feeling. You just have everything. And so it's real nice when you get used to it living up there. All right, next slide. Maybe. And so I thought when I was up there I had invented the selfie stick. I found the biggest wrench we had, some Kapton tape, and that's how I made that video. I taped that camera to that big wrench and then floated through the stack with it. And then I come back and President Obama's out on the lawn with his, and anyway, my patent was ruined. So, all right, next slide. This video right here is more for the kids, but I think everybody will enjoy it. And I just wanted to demonstrate, well, the whole crew wanted to demonstrate, like, what is something simple and what is it like when you take gravity away. So that's just a big ball of water, and now we're throwing a GoPro right into the middle of that ball of water. And so you see those little spheres in there? We had put an Alka-Seltzer into the water bubble, and it really didn't do anything, it just fizzled out, but it made those air pockets in there. And what I really love about this first is just how crazy water is in space. It's really wild. And I love Swanee's face right there. That guy's got a PhD in computer science, but he looks like he's 5 years old playing with the toy for the first time. There's Oleg Artemyev, one of our our Russian buddies, and I wanted to bounce, after we built that water bubble, then I wanted to play with water for the rest of my life. And so I wanted to bounce 2 water bubbles off each other. And in that one, I didn't get it. So I made some smaller water bubbles using a syringe and a Teflon catheter. And then this basically, they give us Sunday off. Sunday is a day off. And this wasted my whole day right here. I could not put this down. I think the Ravens were playing, and I had them up on the background, and I just went for water. So here you'll see, I mean, if you hit it soft enough, you're bouncing water bubbles off of each other, which was just great. And then in a second, I'll take the syringe and I'll stick it in the top. I'll add a little bit of water, and then I'll pull it out and I'll add a bubble of air. And I love what happens with the air. So there's a little water added. I'll suck some air into the syringe and then pump a little air into the water bubble. And now you get an air bubble bouncing around the inner wall of the water bubble. And you can actually see me kind of in the lens through there. And then I'll take the syringe and I'll bounce the air bubble around on the inside of the water bubble. And then we had to know what happens when you put a human in the water bubble. And so, in an unfortunate violation of all NASA rules, we built another gigantic water bubble. Apparently there's electronics that are sensitive to water. But we had towels, we were ready, and Alex didn't have hair, so he got volunteered as the guy to go into the water bubble. And of course, that wasn't room temperature water. We had it down to about 30, just over 32 degrees to make sure it was really pleasant for him. But you can see how wild that is. About a year before we did this, Luca Parmitano was on a spacewalk, and he had water leaking into the helmet of his spacesuit. And he talked about how much it felt like he was going to drown. And I don't think anybody on Earth really recognized that. All he had was about a softball amount of water in his helmet. And he was talking about drowning? How's that even possible? And then when you look at that video and you talk to Alex, water just sticks to you and then it wicks. And he said the creepiest feeling of that was the water going up his nostrils and down in his ear. And he's like, if you couldn't have touched your face, there's no way to get that out. And so that's what Luca was dealing with in his spacesuit. And that started to put in perspective for us how serious that was and how lucky Luca was to make it out of that because he had good skills. All right, next slide. So the next few segments, I'll see if I can keep their attention, maybe not. But this is our daily life in space, and so I got to touch on what are we doing. First, this is about a week in space, and I'm going to miss the tag here and whack my head on the bottom of the gem. But you have to make mistakes to be successful, so eventually I'll get better at flipping around. But about 6 hours of our day, we're a crew of 6 up there, and about 6 hours of our day, 5 or 6, are dedicated to the science. Our crew did over 300 experiments while we were up there. Some are still ongoing, some we completed. And this is really what kept me going. I didn't expect to love the science when I launched, but when I got up there, I really loved it. You're in communications through space-to-ground communication link with all the scientists, the researchers that have spent a lot of their lives working on this research. And we're on the operational end, and we're conducting the experiments for them. And every day you wake up, you don't know what's coming tomorrow. Like it could be these electromagnetic rings, and we were trying to fly formation just using magnetic forces here on these 2 satellites. Didn't work out quite like we wanted it, but the data was awesome. And here they were using some optical devices to do the same thing. We did a lot of fluids research. This is a capillary flow experiment. There will be another one from Germany of just moving fluids around without any pumps, without any valves, just kind of going on their own forces. And when you hear the reaction of the scientists on the ground, when you hear them go, whoa, go back, I did not expect what just happened. You know, pull that experiment apart. Let's really look at what's going on. And that warmed my heart. That was really fascinating. This is a flaming sphere of fuel. And they were looking at this high and then an unexpected lower temperature combustion event. And I loved all that. I was the resident fire burner the first month and a half on station. So all this is burning solids under different oxygen and airflow kind of settings. And it was really fun to get to set intentional fires on the space station. We had 2 unintentional fires, which were a lot less fun, but we had a lot of intentional fires. And in the end of our whole mission, I don't have any video of it, but we were basically a zoo. We had 20 mice with us, we had 12 fish, we had snails, worms. One of our Russians had actually snuck up an onion and grew an onion up there. So it was, I guess he didn't sneak it up. I shouldn't say that. But anyway, it was just a really wild place. We had so much going on. I mean, every single day was just packed, filled with this research we were conducting. All right, next slide. And then there's the less tangible for me research, and that is what's going on with me I changed a lot up there, and the researchers want to know what's going on with our bodies. And Scott Kelly's up there right now. He'll spend an entire year in space, a whole year. And if we ever go to Mars, we're going to need this data for these like 500-day kind of missions to Mars. And so what is going on with our body? My calf muscles wasted away. Even though I was working out 2 hours a day, my calves basically went around to the front of my legs, and I was reshaping. Our eyes changed, the pressure on the back of our eyes changes our eyeball. Some people have some vision changes. So that last experiment, I was looking at blood flow in the back of my eye. And then here, we use ultrasound to map the back of our eye in the shape of basically all parts of our eye. So just sticking that gooey mess up to your eye was a little weird, but it was great data. And it was neat to see. I didn't have vision changes, but they saw the same things in me that would create them. So they said, because I'm young, maybe my eye was compensating for it. We spend about an hour and a half every day on this machine. It's called Reid, and it's basically our weightlifting machine. We also spend about a half an hour a day on our treadmill. Cool part about the treadmill is it's mounted on the wall. So you're running straight down at Earth, but it doesn't mean anything to you when you're up there because there is no straight down and there is no straight up, so you get used to it real quick. We also have a bicycle up there. It doesn't have a seat because you don't need it. Actually, it's in that mock-up. When you get done, you can see our bike that we have up there. And then I put this last little clip in there. It's us freezing all of our, we have urine samples, we have saliva samples, we have skin samples, we have a lot of blood samples, and we have no way to analyze that in space. So we put it in these really cold freezers, and then when Dragon resupply ships come and land on Earth, they bring them back in these cold storage bags, and then we get them straight over to the scientists. And then finally I get the door closed. But it gives me a chance to drink, so that's good. All right, then go to the next video. And then the other part of our day is kind of my favorite part. You know, when you get to the end of a long week and you go home to your house or your apartment, there's probably a light bulb that needs to be changed, there's probably a lawn that needs to be mowed, there's probably a squeaky door, and we have all that on the space station. And so it's up to us to fix all this. Right there is our water reclamation system. So that is actually taking all of our urine and our sweat, and it's sending it through this filter, and it's putting it right back into our drinking supply, our water supply. And then we can strip the hydrogen off of that and vent the oxygen out into the cabin so we can breathe it. So it's a really neat self-contained system that we have up there that keeps us alive. Here I'm working on this furnace. The complexity of that blows my mind, but I have 1,000 people on the ground that are writing my procedures, getting everything together and sending them up to me, and then talking me through these experiments and this maintenance. There, Swanee and I are working on a spacesuit, and we pulled the pump out and then sent that thing out on a spacewalk. Our treadmill broke, so I had to work on that. And of course, even if you got a PhD, it doesn't prevent you from fixing the toilet. And so Swanee is fixing our toilet right there, and it broke on us 2 or 3 times. And when the toilet breaks, it's all stop. Even if Mission Control says keep going, it's all stop. And so we would spend every minute that we could working on the toilet, get it fixing. And actually, it's a pretty reliable machine, and it worked really well with a few hiccups. All right, next slide. And then there's the, how many race fans do I have out there? I think people watch a race because secretly they want to see a crash. Even if you don't admit it, secretly you want to see a crash. Well, when you're in space, you secretly want something on the outside of the space station to break. Because the only way to fix that is to go outside in a spacesuit and do a spacewalk. And so you can see me down at the bottom. I'm just barely hanging on to the edge of the space station right there, And Alex Gerst took this. It's a 10 millimeter lens, so it kind of reshapes the Earth a little bit. But spacewalking. I spent 12.5 hours outside the space station, 6 on this spacewalk, and then 6.5 on my next one. It's the hardest thing I've ever done in my life. I would take 100 night carrier landings over one spacewalk. It was just physically grueling, mentally grueling, and you know that every single thing you touch, if you don't tether it, you're going to lose it, and then they're going to make fun of you. Or if you break something, now you're going to have to do another spacewalk to fix what you broke, and that would be very poor form. So that was great. And one anecdote that I'll tell, just because it's cute. I'm pretty scared of heights. Like, I can survive here, but if I went up on the roof, I don't know that I could hang out on the edge. And so when I launched into space, I didn't know if I would do a spacewalk, but my wife told me, Reid, if you open the hatch and you freeze and you don't make it outside, just don't even bother coming home. You don't even bother coming home. So I had that motivation when I got the hatch open. I knew that my wife would not accept me back into the house if I messed that up. So Alex and I were 2 rookies, first time in the space station program that 2 rookies went out on a spacewalk together. We got the hatch open, and I was looking straight out this hole. It's about this big, straight down to the Earth. And it was the middle of the night. We were over the Pacific Ocean, and the moon was kind of illuminating the clouds, and it was just this feeling. First, I thought cold air should rush in, but there is no air, so that didn't happen. And then after that, it was just like my best friend out there just saying, come on out. The water's great, let's go. And I went outside, and yeah, it was exhausting, but it was really a wild, wild experience. Well, this doesn't work, so I need next slide. All right, so let's get on to some of the pictures. And it'll help if I use a laser pointer, so what I'll do on some of these pictures is I'll point to this one, and then I'll point the same thing out on the other slide over there. I'm floating here in the cupola. It's a series of 6 windows, goes around in a 360-degree kind of field of view, and then out the center is a big, it's like a manhole cover, a big hubcap, so you can look straight down the Earth. All right, next slide. And I got all of these images, all these videos that I'll show are through about a 40-millimeter lens. So for the kids, if you want to know what it's like to be in space, what it's like to look down, these images are exactly what the human eye sees when you look out. So this gives you a feeling of that curvature of the Earth that you see behind me there and in these slides. And I'll point out here, we're coming up on the coast of California, so you got the Central Valley here, and then down to LA, down here, and off to Baja, California. So coast of California, you can see the fog rolling into San Francisco, and then the Central Valley, and then it goes down into LA and Baja. And for me, as just a human being, like this is the best. Looking out at your planet, it's amazing in every way. And I'll use that word probably 1,000 more times, so I'm sorry if I beat up the word amazing or phenomenal. All right, next slide. Anytime you can catch the sun low on the horizon and get this sun glint off the ocean and give your clouds some shadows beneath it is great. But you also see in this, and it's hard over on that screen, but you just start to see our atmosphere. And that little blue fuzz out there, that's it. That's all that we have. That's everything. It just looks like wind would just come along and push it off, and it would be gone. And we would be like Mercury. But it just stays there, and it's incredible to me to just look down and see how tiny that little atmosphere is, that little bit of fuzz. All right, next slide. When I launched, we were in this period called high beta, where the sun never set. So this is 1 photo a minute for an orbit of the Earth, and you can see it just loops, and the sun just makes this circular pattern. And if there's any engineering-minded folks in the audience, the space station is going through a cycle of about 300 plus to 300 minus in temperature. But when we are in this phase, the sun never sets, and so it's just heating up and heating up and heating up and heating up. And so it's really hard for our flight controllers to manage our thermal systems when we're in this phase of flight. So as astronauts, we loved it because it was different and cool, but the flight controllers, man, they didn't like it at all. And if we would leave our window shutters open for too long, they would call us, and they have little temperature sensors, and they would say it's getting too hot, so we would close them back up. But it's neat. All right, next slide. Okay, so in the Navy, I spent a lot of time in the Middle East. So this is going to be just a quick photo tour through the Middle East. These are oil wells that are kind of burning off their, I'm guessing, natural gas right here. And those always pointed down to Iraq. So we're looking to the south, and this is Iraq. And just to catch everybody up over here, there's those fires of the oil wells. And then this is Iraq down in here. And then as we kind of loop around counterclockwise, we come up to the city of Kuwait. So that's Kuwait right there. And then we go up to Riyadh in Saudi Arabia. That's Riyadh there. And then as we work our way down, Kingdom of Bahrain and Qatar are right in there. Bahrain and Qatar. And then we get our way down to Dubai. Spent a lot of time in Dubai. Maybe some of you have been there. It's a pretty neat city in the middle of the Middle East. And then all of this over here is Iran. And so just in one look out the window, you get all those countries and all those conflicts and all those people. All right, next slide. I hear a lot of people say that you can't see borders from space. And I'll see if you guys can find one. This is San Diego, and this is Mexico, and that is not added in Photoshop. So over here, San Diego, Mexico, and then our border. So you can definitely see borders, especially at night. And I'll show you a couple others in a minute here. All right, next slide. Sometimes you can get this low sun angle that throws these shadows off the clouds that just spill off into the galaxy, and it's just amazing to look at. And no picture can do that justice, but I love that image. Next slide. Here's another shot of one of my favorite parts of the world. So we have the Nile River coming up here, and here's Cairo and the pyramids. So this is the Nile. You can see it's all green around the Nile and the pyramids in Cairo. And then we got the Suez Canal, which spills out into the Red Sea, Suez and the Red Sea. And then we go up here to the Dead Sea. I got a camera in the way. So we got the Dead Sea here. But then I want you to look at desert, 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 and then right here, it's like this gray. So looking over here, it's like all desert, and then there's gray. And that gray is people building. And that's Israel and Lebanon. And that's just urban development. It just takes the desert and makes it gray. It's pretty incredible to look. And if you just think about the millions of people right there in that one image, they're just making that gray right there. All right, next slide. This is a pretty neat one. This is Bangkok. And then it's hard to see over here, but these are like thousands of green lights. It's easier on this one. Thousands of green lights down there. And those are all squid fishing boats. And they take these green lights and shine them in the water, and squid come up to the surface, and the fishermen just take nets and scoop them all up. And so luckily, if you see a green light today, I guess I'd run in the other direction. I don't know. But that, I would never want to be a squid in there. All right, next slide. This is cool because a little kid asked me, he sent me an email and said, why don't I ever see stars from space? And I went down to the cupola, and I put the camera up to the window, and I took a 2-second exposure. So I left the shutter open for a little longer than you normally would. And this was the result, and it blew me away. So you see the solar arrays here, they're a little bit blurry, the solar arrays. And then you see just thousands of stars. But wow, what is going on with our atmosphere right there? What is up with this red band, this green band, and then this yellow underneath? So this green band right here, we define space as 100 kilometers off the surface of the Earth, and that is that green band right there. The green and the red are atomic oxygen, releasing photons at different wavelengths. And then this yellow, I'm not 100% sure on, but some people have said it's sodium from meteorites that have burned up in our atmosphere, and it's just always kind of floating around in there. But it gave me a whole different perspective of what's going on in our atmosphere. It's really wild. Next slide. It's like we have a force field around our Earth. You get to look down on natural disasters that look beautiful. So here is a very powerful hurricane, but from my perspective, it's absolutely beautiful. And next slide. I love this one. The northern lights are over here to the left. So you got Canada up there on the northern side. And then as we come down the coast here, there's a little white set of lights right there. Vegas, baby. Las Vegas. Right in the middle of the desert. And it sticks out like a sore thumb. All right, next slide. We're almost to the end of our photo tour. This one sparked my post-flight vacation. This is the Bahamas looking straight down. And that water is so gorgeous. I sent this to my wife and said, let's go to the Bahamas when we come home. And so we took a cruise there in January. I'm not supporting the Bahamas or Bahama tourism, but it's beautiful. I mean, that was amazing. All right, next slide. Anytime you can look at the northern and southern lights from above and kind of fly through them as they're floating and flickering around, it was awesome. Next slide. And this is London. This is not human eye perspective. This is taken with a lot of magnification. And you can see the River Thames rolls through. Here's the big Ferris wheel. And then look at all the buildings that are shadows in the river. So here's the Ferris wheel. And then all these buildings make great shadows in the river. But then if you look right here, that's the Tower of London. It's real hard to see on this screen. It's better over here. And just surrounding that is a little bit of red. And those are 400,000 poppies in a war memorial that people had put there. And I didn't even know it was there. And people on Twitter kind of responded that that was what was going on. And I made that picture really rich and genuine to me. I love it. All right, next slide. If they can leave the audio down, I'll just explain what's going on here. We're flying over the Atlantic Ocean. And just on the horizon is this kind of brownish soot. Over here, it's easier to see. This kind of brownish soot. And as I come out to the right, I'm looking more towards the south now. And that soot now takes up about half of the ocean there. This is all just kind of sand and debris. And as I pan further to the right, it's kind of over Brazil. And so what is going on is there's a big windstorm over the Sahara Desert in Africa, and it's lifting up sand, carrying it across the entire Atlantic Ocean and depositing it in Brazil. So just imagine for a second that you wake up in the morning in Brazil, you're in the rainforest, and your car is covered in dust. And there is no way you would ever say, this is sand from the Sahara Desert. I mean, this was the moment that I had that feeling in space that our Earth is incredibly alive, and it is changing at all times. It's reshaping, it's redefining itself, and we're little guests that are just a part of this bigger Earth journey. All right, next slide. Here is, just real quick, here is Paris, here is London. So you got Paris and London. And then I'm covering it up, but there's a great border right here that you can see where the chemicals in the lights change from the street lights. So it goes from yellow here, and then you can see them start to turn real white in here. It's probably easier to see over here where that border goes. All right, next slide. I put this in because of yesterday afternoon. So, I mean, my phone was going crazy with weather alerts and all that. And if we look real hard, the Chesapeake Bay comes up here, and this is about DC, right around in here. So Chesapeake Bay should be coming up in there. And this is that August thunderstorm that when I was a kid growing up in Baltimore, every afternoon, this is what kicked you out of the pool. And so that's a picture of that. And I called my parents and told them to go inside that day because it's coming right for them. But that's probably what yesterday looked like. All right, next slide. And I don't need the audio here. This is a video camera out the window at night. And we have, I'll do it over here first. We have DC, Baltimore, Philadelphia, New York, Boston. You can barely make out Ottawa, Toronto, Buffalo. And what you don't see, so I-95 just paints this path up the east coast of the United States. It's incredible at night. You just see the lights all the way up. And what this video doesn't show you is if you look straight down, you go through Richmond and then look out the back window of the space station and you're all the way down to Miami. And just think about that. I mean, that's everybody I've ever known right there in one shot out the window. All right, next slide. People ask me my favorite photo from space, and this is it. Let's use this screen over here. Sorry for you guys, but the resolution's just a lot better. So Italians are great people. They outline their country. They make great sports cars. And it's really easy to see their whole country from space. So as we work down from the north, that's Rome, and the Vatican is there. We got Naples. Come down to the boot of Italy, and this is the island of Sicily. And then right here is Mount Etna. It's a black ring. And then that little one dot in the center, that's lava in the volcano. So I really love it. And then up on the rim, you got the sun rising way off in the distance, probably over Japan or even east of that. And I just love that. When you come up over Europe at night, it's really magnificent. All right, next slide. And then people ask, are there aliens? And so for the kids, as you're walking out, make sure you look at that image because there is no way you can look at that many stars and not think that there's planets around every one of them, and somewhere on those planets there are people or green slugs or weird worms or something crawling around on those planets. All right, next slide. After 6 months in space, it's time to come home. And that's us all hugging each other and getting ready to board our Soyuz spacecraft to come back. This is Yelena Serova, a female Russian cosmonaut. She did a fantastic job up there. They hadn't launched a woman in quite a long time, about 20 years, and she just crushed the program. That's Sasha Samokitayev. We would leave them up there. Barry Wilmore, an American, and then Yelena and Sasha would stay up. Undocking is just like coming up. I hit one button in the left seat of the Soyuz, and it opens up these hooks, and these spring pushers just push us slowly away from the space station. There you see it. The difference is there's a lot more fire on the way home. So this is a view out the window as we're burning up coming through the atmosphere. And all those little flakes are parts of our ablative heat shield, so we're actually disintegrating a little bit as we're coming through. It's supposed to happen. It's a weird feeling. You're 3,000 degrees, somewhere in there, maybe a little less than that, and your window is slowly getting more and more charred. And then after about 4 or 5 minutes of high G, the parachute comes out, and then you can see the landing here. They call it soft. It is anything but. And then you're home. And your parachute deflates, and our rescue forces were on us immediately. We had basically a pinpoint touchdown. And you can see here, when it goes to the next slide, we had a little surprise where our parachute reinflated and it drug us about 200 meters across the floor of Kazakhstan before they got us out. And there's me in the capsule. And then the next picture is a great one from Bill Engels of them pulling me out. You can see how charred the capsule is. And then there's that sitting in the seat and a euphoria, this adrenaline rush, unlike any I've ever experienced in my life. And that lasts about 20 minutes. And then when that goes away, you start to feel reality and gravity, and it is awful. I mean, everything is heavy. Your stomach is sick. You know, you don't have as much blood. Your body sheds blood when you're in space because it doesn't need as much. And so you're lacking in blood. You get dizzy real easy, and you got to learn to walk. Your calves haven't walked. Your heels haven't felt weight, and your legs are twitching, and you're trying to balance, and it takes you a few days, and then it kind of all works its way out. So that's the end of my sales pitch for why being at NASA is a great thing. And it is a great thing. And all I touched on today from the NASA perspective was just this little tiny part of NASA that's human spaceflight. And you think right now we're about to have a spacecraft go by Pluto here in just a few weeks. It'll be the first time we get a close-up look at Pluto. We're going to Ceres. We have 20 satellites in orbit around our Earth right now, looking down at our Earth. We have rovers on Mars. We're out towards Venus. I mean, we're going to the sun. We're everywhere in our solar system. It's pretty neat time for NASA. So I'd like to open it up for questions. I don't know how we're doing on time, but I think we got some time for questions, maybe 10 or 15 minutes. And for the person running the projector, if you could just play the next video in that PowerPoint, and kids are allowed to laugh. There's some funny stuff, us just goofing around. I'll let you guys decide who's asking.
Are we starting with online question?
That's morning coffee delivery. So Alex would make the morning coffee and deliver it to me in my crew quarters, and that's me catching the coffee. And then I would make the afternoon coffee after lunch and deliver it to Alex in his crew quarters. It was kind of our rule. She just asked, did I grow 2 inches when I was in space? And I absolutely did. I made it almost to 6 feet tall. In Node 1, which is right in the center of the space station where we eat dinner, it's really cute. How many of the parents out here have a size chart on a wall with their kids? And so there's a tape measure on the wall in Node 1, and you can see like dozens of astronauts. And we have one, Garrett Reisman. He's a pretty short guy, and he's got the biggest name on there, like Garrett, 2 inches taller. And we did grow quite a bit. And then as soon as you come back, gravity just says, and it shrinks you back down. Did we get the audio working?
I think so.
Well, we can always ask questions, and I can repeat them. So.
Could you describe what your senses picked up when they opened the hatch on the Soyuz upon landing?
What did my senses pick up when they opened the hatch on the Soyuz after landing? I could give you a long version, but we landed and then we tipped over, and we got dragged a bit. And so then at the end of being tipped over, we had Alex was down there, Max was right here, and I was up above both of them. And we'd already started taking our gloves off and all that, so it was a bit of chaos in the capsule. And Max asked us how we're feeling. And my only response to that was, Max, I think I'm going to throw up. And at that, the 2 guys under me, now we got gravity, are like, oh no. And so they're closing their visors and they're getting ready. I did not throw up. I did not. I made it. But when they opened that hatch, the first thing that I wanted to do was I wanted to look out at grass. And we had a little snow on the ground, and you felt that cold air rush in and hit your skin. And on the space station, it's 72 degrees, period, every day. And just feeling cold air wash over my sweaty face after reentry was superb. And then the feeling is just adrenaline. I mean, it's just like you have survived this incredibly crazy 15 minutes of fire and parachute, and you're flipping around and smashing into the ground at a high rate of speed, and you're alive. And I wanted to talk to my wife and my parents, and I just wanted to celebrate life.
We've got an online question next. Did the northern or southern lights have any effect on the instruments on the ISS?
I was our IT guy. I worked with the computers up there, and we had some really big southern lights while we were up there for some solar storms, and it was always good after you go through. If the southern lights if they come up far enough to the north that your spacecraft is actually flying through them, then you're going to have hard drives to replace on your computer. So the thing that we mostly saw was hard drives going out. We never saw any of our technical gear kind of quitting on us, but hard drive replacement was definitely common.
Hi there. So we met earlier. I teach middle school at Jefferson Academy down the street, and in middle school, kids learn ratios and long division and reading and writing and the scientific method. But besides those subjects you learn in school, what are some things that you need to have to become an astronaut like you?
Things that you need to have to become an astronaut besides the core fundamental math science stuff. To answer that, I would look at my class of astronauts, and then in 2013 we hired 8 more folks. And Katie Coleman, who's also an astronaut, kind of argued this with me a little bit last night, but we all had operational kind of backgrounds. We were researchers in the field. We were pilots in aircraft. We were trauma surgeons in the trauma center operating on people. And when I look across the modern astronauts, it seems to me that those skills, those life skills of being out and doing with your hands and your mind, that seem to be what is driving our core right now. So that's what I would say is, find something that you love to do and then go out and go all in on it and do it.
What was the biggest surprise you had?
The biggest surprise I had, there was about 1,000 big surprises. The first big surprise I had was that it's really hard to eat peanuts. That's a really big surprise. You open a bag of peanuts in space and you have peanuts absolutely everywhere. So my solution to that was I quit eating peanuts. That was how I solved that one. Other big surprises, watching lightning from space, watching our Earth from space. I expected it to be beautiful. I didn't expect it to be as captivating. You could never float by a window and not take a few seconds to look outside. It was really great. And then another big surprise was just how great it felt to be back on land, to eat a salad, to drink a soda, or to eat a pizza. Those are the things that I kind of missed. And then at the end, to sit down and just relax and feel gravity was great.
All right, we've got an online question next. What is the most needed but currently missing technology for the next giant leap forward in manned space exploration?
I would say just working on reliability and then working this is me personally, and this is not my field of study. So NASA, there's a lot of great scientists that could answer this question a lot better than me. But if we go to Mars, I think the one big missing piece is shielding us from the radiation while we're on that journey. And we all wore dosimeters while we were up there to watch our radiation, and that's a big deal. When you get outside of Earth's protective magnetosphere and the atmosphere, it's like airline pilots have to deal with that all the time because they're flying at 40,000 feet, so they're getting more radiation throughout their lives. And so I think that's still one hurdle that we got to look at. Reliability, radiation, but we're on our way.
The last 35 years, we've gone through the shuttle program and the construction of the ISS. What do you foresee the next 30, 40 years bringing for manned space exploration?
Quick answer, humans on Mars, and you can pay to go into space. That's it. Yeah.
Join me here in the center of the stage then. Let's all join together in thanking Reid Wiseman for this incredible journey. I think this is the liveliest, most vivid account we've ever heard here.
All right, I didn't even do a jig.
So who wants to go? Anybody else want to go to space after hearing this? Yeah. We'd like to thank our online audience and our television audience as well. Our live audience, our teachers, students, and families who are here today. And also especially we'd like to thank Boeing Corporation, which makes these programs possible. So thank you, Boeing. That was
Thank you.
terrific.
Thanks.
Thank you for the...